Cryptography is the science of hiding information using secret codes. Although there's evidence of cryptography dating back to the ancient Egyptians, the rise of computer technology has led to codes that no human could break without the aid of a computer. In this lesson, you'll learn about how cryptography works in C# and prepare some information to be encrypted. You'll carry out the actual encryption in Lesson 3.2. To begin this lesson, open the Textland project from your Sample Files folder. And view encryption.aspx in Design View. The text box on this page contains some military orders from World War II. In 1944, the Army would have had to encrypt and decrypt these orders by hand, but when this page is complete, it will be able to encrypt and decrypt the orders in less than a second. Now open the code behind file of encryption.aspx. And add the following using lines at the top of the page. Using system.security.cryptography. System.security.cryptography contains ASP.NET's encryption algorithms. Next, using system.io. System.io contains the stream objects that will be needed for encryption. And finally, using system.text. System.text contains the methods you'll need to convert text into binary data. Now you'll need to add some code to prepare the text for encryption. Add the following code to the button encrypt click event handler. Byte bytes to encrypt equals encoding dot UTF-8 dot get bytes begin brackets text box encryption dot text. This converts the contents of the text box encryption control into a byte array representing binary data. You learned about byte arrays in Lesson 2.4. Encryption in C# always works with binary data, so you'll have to convert anything you need to encrypt into a byte array. In order to convert string data into binary data, it must be encoded using the encoding class. Different encoding standards will produce different binary data. In this lesson, you encoded the text with the UTF-8 standard. All encoding standards are capable of handling standard English letters and numbers, as well as most symbols. The differences between encoding standards appear when working with different languages, as some characters will not be supported by all encoding standards. Now add the following code on the next line. String encryption key equals text box encryption key dot text dot pad write 32. Byte encryption key equals encoding dot UTF-8 dot get bytes string encryption key. An encryption key is always needed when encrypting data, and will be needed in order to decrypt the information again. The AES algorithm requires a 32-byte, that's 256 bits, encryption key. So this code uses the pad write method to pad the text if the user has entered a key that is less than 32 characters long. Now add the following property by placing its code outside any event handlers. Byte initialization vector equals new byte 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. The AES standard requires an initialization vector as well as an encryption key. An initialization vector is not unlike a secondary encryption key, as its presence makes the encryption harder to crack. If you use an encryption standard that requires initialization vectors, you will need to keep a record of the initialization vector, as it will be needed, along with the encryption key, to decrypt the data. If you use an encryption standard that requires initialization vectors, you will need to keep a record of the initialization vector, as it will be needed, along with the encryption key, to decrypt the data. It's not recommended to reuse initialization vectors. Someone trying to crack your encryption can detect patterns arising from repeated initialization vectors. This may enable them to break your encryption. The initialization vector I've used, that's sequential numbers from 1 to 16, is just about the worst initialization vector you could possibly use in a real-world situation, as it can be easily guessed. You'll use your binary data, encryption key, and initialization vector to encrypt the military orders in the next lesson. That's Lesson 3.2. Close Visual Studio now, saving your changes if prompted. You've now completed Lesson 3.1. Understand cryptography and prepare data for encryption.